Okay, now we're in chapter 2. In this section, we're going to concentrate on qualitative data. Remember what it meant to be qualitative. So when data is collected from a survey or an experiment, they must be organized into a manageable form. Data that's not organized is referred to as raw data. So we're going to talk about organizing data in tables and graphs and later numerical summaries. A frequency distribution lists each category of data and the number of occurrences for each category of data. So let's look at an example of that. Okay, for example, the data below represent the color M&Ms in a bag of plain M&Ms. So it asks us to construct a frequency distribution of the color of plain M&Ms. So if we are constructing a frequency distribution, and something I'm going to skip here when I'm drawing these graphs, but for our information, any charts or tables or graphs that you create or that you see anywhere, they need to have a title and a source, right? That's really important. Okay, so we would title this one Color of M&Ms in a bag of plain M&Ms, but I don't have a lot of room here, so I'm going to leave that off, leave the title off. All right, so frequency distribution is just, I'm going to put color here. It's just a table. Okay, and then I'm going to have a tally. And then we're going to have frequency. So this middle column, it can be left off. Okay, but it's kind of nice to have. All right, let's see first of all how many colors we have. So brown, yellow, red, orange, blue, green, blue, brown, yellow we've already counted for, brown, red. That's all of them, right? 1, 2, 3, 4, 5, 6. Okay, so it needs to have 6 rows. Whoops. Let me see if I can redo that one just to make it a little more legible for us. I can barely redo it. Okay, our first column will be whatever the characteristics of our data are and what we just discovered up there. So we have brown, yellow, so in this case it's just our different colors, red, orange, blue, green. Whoops. Okay, so brown, brown, yellow, red, 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 brown, orange, blue, green, blue, brown, yellow, yellow, brown, red, red, brown, 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 green, blue, green, orange, orange, yellow, 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 red, brown, red, brown, orange. Green, red, brown. Yellow, orange, red. Green, yellow, yellow. And then brown, yellow, orange. So you can see how it's handy to have the tally column. Okay. And then you just put your frequencies over here. The number of times that brown occurred was 12. That's how frequently it occurs. 10 for yellow, 9 for red, 6 for orange, 3 for blue, and 5 for green. Okay? Now, in any frequency distribution, it's a good idea. You don't see it 100% of the time, but it's a really good idea to have a bottom row with your total and add these up. So there's 22, 31, 37, 45, and make sure that matches how many instances you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5. So good. All right, now I'm going to take a second, guys, to make a note of those because I know I'm going to need those numbers in my next example. Okay, so brown, yellow, red, orange, blue, green. Okay, so I can refer to it without going back. Okay, so the frequency distribution, also called a frequency distribution table. Okay, and it's just a table, but generally that's always where we start our organizing of our data, by drawing a frequency distribution table. Okay, often we want to know the relative frequency of the categories rather than just the frequency. Okay, so the relative frequency is the proportion or percent of observations within a category, and is found by taking the frequency and dividing it up by how many there are, right? So a relative frequency distribution lists each category of data with the relative frequency. So for example, if we were asked to construct a relative frequency distribution, right, we would use, let me get my pen, we would have that same table. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then our total. Okay. Okay, so we had brown, yellow, orange, blue, green at 12, 10, 9, 6, 3, 5. Wait a minute. Brown, yellow. Oh, I left off red. brown, yellow, red, orange, blue, green. Total. 12, 10, 9, 6, 3, 5, 45. Okay, so for a relative frequency distribution table, we would just add an extra column over here called relative frequency. And to find the relative frequency, you just take your frequency and divide it by the total. Right? That's where that comes from. Let me get my calculator. So 12 divided by 45 is approximately, right? Approximately 0.27. That's rounded. So we got to think about that also. 10 divided by 45 is about 0.22. 9 divided by 45 is 0.2. 6 divided by 45 is approximately 0.13. 3 divided by 45 is about 0.07, and 5 divided by 45 is about 0.11. Yeah, 0.11. Okay, so that's a relative frequency distribution. Okay, now it's also a good idea to add up your relative frequencies and make sure they equal 1. Now notice if I added up my fractions, because they all have the same denominator, all I have to do is add the numerators, 22, 31, 37, 45. Notice that should always equal 1. If we only listed our decimal approximations and we add those up, let's look what we have here. 11, let's just for clarity's sake here. Okay, so 11, 13, oh, look at that. 2, 4, 6, 7, 8, 9, 10. Okay, well, that's a fluke that those came out to 1 because of rounding, right? You may not get exactly 1, but you better be really close. Okay, but when you're adding the fractional values, it will equal 1. So that's also a good check for us, just like having this total here. Okay. Okay, once raw data are organized in a table, then we can create graphs. So a bar graph is constructed by labeling each category of data on either the horizontal or vertical axis, and the frequency or relative frequency, shoot, I didn't keep my frequency, so it's okay, we can recreate them pretty quickly, of the category on the other axis. Rectangles of equal width, that's important, are drawn for each category. Okay, the height of each rectangle represents the category's frequency or relative frequency. So this is asking us to use the M&M data that we've already organized in our table, right, to construct a frequency bar graph and a relative frequency bar graph. Okay, so if we're doing a frequency bar graph, again, don't forget it really needs a title and a source. But I'm going to make a bar graph. And I want to look over at my table, and I notice that the biggest number is 12, so my scale over here has to go up to at least 12. So maybe I'll go by 2s. 2, 4, 6, 8, 10, 12, 14. Okay. And this vertical column is always labeled frequency. Always labeled frequency. Right? And then down here, we have color. So what do we have? Brown, and I'm just shortening these, right? Yellow, red, orange, blue, green. And I'm going to draw a rectangular bar. The first one needs to go up to 12. Okay, now I'm doing this freehand. Normally we would use a ruler and be a little more precise, right? Yellow needs to go up to 10. Red to 9. Orange to 6. Blue to 3. And green to 5. Okay, so drawing freehand on this device I'm using on the computer, it looks pretty bad. But something we need to remember that's really important is make these widths of your rectangles the same size. Okay? All right, so let's do the relative frequency graph. It would be exactly the same, except over here, instead of frequency, we're going to have relative frequency. Okay, so let's see. What was our highest one? Is 0.26. So maybe I might go 0.5. 0.05, 0.1, 0.15, 0.2, 0.25. Okay, so it would be the exact same thing over here, and we'd put color. Now, I did not make a note of these relative frequencies, so I'm not going to take the time to go back and recalculate every one of those, but it'd be the exact same thing. The only thing is our bar would go up and correspond to the relative frequency, right? Now, graphs that start with some scale at values other than 0, right? Notice this was always 0. Or that have bars with unequal widths or different colors or three-dimensional, right? A lot of times those can really misrepresent your data. And computers are really fancy now, and we draw these things on computer programs and try to make them fancy, but it's really misleading and not a good idea. Just a plain, simple, regular old bar graph. Make your bars the same width. Okay, now the order of the categories, notice right here, these aren't really in descending order. It doesn't usually matter, but there are special kinds of bar graphs, right, where the categories are arranged in decreasing order of frequency. And they're called Pareto charts. So a Pareto chart is a bar graph where the bars are drawn in decreasing order of frequency or relative frequency, right? That order would be the same. So here's the relative frequency bar chart as a Pareto chart. Okay, and the only difference was these two got swapped, right? Okay, Let's see. So side-by-side bar graphs can be used for comparisons. Data sets should be compared using relative frequencies. That's important because different sampling or population sizes, typo, or population sizes, make comparisons using frequencies difficult or misleading, right? So you really need to use the relative frequencies. So it says the following data represents the marital status in millions of U.S. residents age 18 years of age and older in 1990 and then again in 2006. Draw a side-by-side relative frequency bar graph of the data. Okay, so all I did was I took this chart it asked us to, and I just recreated it up here smaller so that we could look at the bar graph as we're talking about how we would create this. The first thing we need to do is make this relative frequencies, right? So for example, let's look at what that means. Let's add these numbers up. So notice how handy it would be if we already had the total down here. It's really useful to have your total, but a lot of times they'll leave that total off of their frequency distribution. So 40.4 plus 112.6 plus 13.8. No, sorry, tap on my calculator. I got to start over. Okay, 40.4 plus 112.6 plus 13.8 plus 15.1 for a total of 181.9. Remember, that's in millions. And over here we've got 55.3 plus 127.7 plus 13.9. Very close. Plus 22.8 for 219.7. So if I'm getting the relative frequencies, let's just do the never married to start with. Okay, 40.4 divided by 181.9 is 0.22. So that's approximately 0.22. 55.3 divided by 219.7 is approximately 0.25. Okay, let's do this widowed because the numbers were so close and maybe it'll help us show what we were talking about. 13.8 divided by 181.9 is 0.075, and 13.9 divided by 219.7 is 0.063. So this is why you need to use relative frequencies if you're doing a side-by-side comparison bar graph. Okay, if I use the numerical values, look, this is a smaller number in 1990, but proportionally it's a larger percentage of the total population. Okay, so you'd make all of your relative frequencies and then you'd graph them exactly like we did earlier. Choose two different colors. You gotta have a key for a side-by-side graph. Okay, so the never married in 1990 goes up to 0.22, your bar goes there, and right beside it, side by side, then you draw one up to 0.25. Okay. Okay. Horizontal bar graphs. Bar graphs may also be drawn with horizontal bars. Horizontal bars are preferable when category names are lengthy, like this. Right? But notice if we just turn this 90 degrees, okay, counterclockwise, it's just a regular bar graph. right? And this one in particular is a regular side-by-side bar graph. Okay, and then finally, for this section, pie charts. Okay, a pie chart is a circle divided into sectors. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. Okay, so the following data represent the marital status in millions of U.S. residents 18 years of age or older in 2006. Draw a pie chart of the data. Okay, so here's our frequency distribution table. Once again, I need my relative frequency. So I'm going to add these up again. 55.3 plus 127.7 plus 13.9 plus 22.8, 219.7, and I'm going to find my relative frequency. So 55.3 divided by 219.7 is 0.2517. So we're going to round that to 0.25, and notice for never married is the blue sector, and they've got 25%, which is 0.25 as a percent. Okay, let's do one more. Okay, the widowed, we did that earlier too. So just as an example, 13.9 divided by 13.9 divided by 219.7. Okay, 0.063. So, and notice they've just rounded that to 6%. Okay, but if I were actually constructing this chart, these percentages aren't sufficient for me being able to draw that. You know, the 25%, oh, I know, is a fourth of that circle, so that's pretty easy. But 6%, how big of a wedge, a sector, do I make for 6%? So then we would have one extra step. Okay, all the way around a circle is 360 degrees. So if I took 25% of 360 degrees, of means multiply, right? 25% of 360 degrees is 90 degrees. So I would know I would need to make that sector 90 degrees. So let's look at this one. Okay, 0.06 of 360 degrees. Okay, of means multiply. So 0.06 times 360 is, let me do that again, 0.06 times 360 is 21.6. So then we would use some kind of tool, right? A protractor, or on the computer we just enter the degrees to draw this sector at a 21.6 degree angle. Okay, with a pie chart, we must also have a key. Must have a key. Okay, pie charts are useful for showing the division of all possible values of a qualitative variable into its parts. Okay, because angles are often hard to judge in pie charts, they're not useful in comparing two specific values of the qualitative variable. In other words, if I had another pie chart of the, what was it, 1990, notice these would basically be about the same size for the widowed, and I couldn't really tell the distinction between them. So instead, the emphasis for a pie chart is on comparing the part to the whole. Bar graphs are useful when we want to compare the different parts, but not necessarily parts to whole. Okay, that wraps up our first section in Chapter 2. Let me know if you need anything.